Okay, so what we're going to look at in this lesson here is electricity calculations. So we've been talking about voltage, current and resistance. So what we want to do now is we want to look at some calculations that can come up that you may be asked to do. So what we have here is we have this triangle, and we can use this to figure out, for example, we can figure out like how to calculate for voltage, how to calculate for current, and how to calculate for resistance. So just as a reminder, V is voltage, and sometimes they call it potential difference, like you can see here, voltage or PD, just abbreviated. I represents current. And if you remember, current is like the flow of electrons flowing past a point on the conductive material or wire every second. And then R is resistance. So we use this. So as an example, if I wanted to figure out how do I calculate for voltage for V, well, all I have to do is I just cover this like so, and it tells me here that that voltage is current multiplied by resistance. If I want to work out what current is, I cover this, and it tells me that current is equal to voltage divided by resistance. If I want to work out what resistance is, I cover this, and I can see that resistance is voltage divided by current. So let's have a look. Let's have a look at an example here. So in this one, question 1, so calculate the potential difference or voltage. Sometimes voltage will be called potential difference. So calculate the potential difference or voltage. So we know that that is V. Okay, so we've been asked to calculate the potential difference or the voltage. So we look here at our triangle, we cover up V, and we can see that voltage is equal to I, which represents current, multiplied by R, which represents resistance. So we can write in this formula. What I would say as well is when you're working these out, just show the workings out of your calculation. This will be the same for maths. If you're doing maths as well, just always show each of your steps within your calculation. So we cover this, and it tells us that voltage is equal to current multiplied by resistance. So I can just write this in here like so. So voltage is equal to current multiplied by resistance. So now we can read the question and see what does it give us. Okay, so it tells us calculate the potential difference. So that's what we're trying to calculate, V, across a resistor of resistance 10 ohms. So remember, resistance is in ohms. This is the symbol for ohms. And resistance, which is I. Okay, remember this is represented by the capital letter I. So that's that. So we can just write in what we have. So I is equal to 10 ohms, like so. So calculate across a resistor of resistance 10 ohms if the current flowing through it is 2 amperes. Okay, so current, remember, is represented by the letter, sorry, this should be an R. So that's resistance. And current is represented by the letter I. So I. So I, it tells us here the resistance is 2 amperes, or the current, should I say, is 2 amperes. So once I've put in all of my parameters, what I can do then is I can just work this out. So voltage then, let's just do this in black. So voltage is going to be equal to I, which is current, 2, okay, I, multiplied by the resistance, which is 10 ohms, multiplied by 10. And this is equal to V is going to be equal to 20. And voltage is, like the unit for voltage is volts. So it's just VOLTS. Okay, so amperes is the unit for current, ohms is the unit for resistance, and then volts is the unit for voltage. So we'll just write this up here. So current is in amperes. So it's just a unit, and resistance is in ohms. Okay, and ohms comes from, it's named after the scientist George Simon Ohm, who discovered the relationship between the current and the potential difference, okay, which is known as Ohm's law, which you would have done a little bit of research on there for the last assignment I gave you. So that's it. There's nothing really more complicated about these calculations than that. So it's just important that you know, like that you know this triangle here. It's very useful. So it's just and it tells us how to go about calculating whichever property it is that you want to calculate. Okay, so this one we're asked to calculate potential difference. So again, you cover this, write down what you have from the question, and plug the values into your formula, work it out, and then write what it's asking you for, and make sure and just use the correct units then as well. So let's have a look at the next question. So question 2 then is calculate the current flowing through a resistor of 20 ohms when the potential difference, and remember this potential difference is just another word for voltage. So that is going to be, that's V. This is R, and we're looking for the current. Okay, so what we do is we go up here, we cover what we're looking for. Okay, so we can see that the current is equal to voltage divided by resistance. So current is equal to voltage divided by resistance. We can just stick in what we have. So current, this is what we're looking for, and it's represented by the letter I, is equal to voltage, which is represented by the letter V, divided by resistance, which is represented by the letter R. So we've identified the correct formula that we use in order to work out what the current is. So what we can do then is we can just, from the question, we can write in what we have. So we have voltage, so it tells the potential difference is 6 volts. So V is equal to 6 volts. It tells us the resistance of the resistor, which is 20 ohms. So R is equal to 20 ohms. Now what we have to do is we have to work out what I is, or what the current is. So now we just write in what we have. We put it into the formula. So we put the actual values into the formula. So I is equal to voltage, which is 6, divided by resistance, which is 20. Okay, and then what we can do is we can use our calculator to work out what that is. So we have 6 divided by 20. That's equal to 3 over 10, which is equal to 0.3. So I is equal to 0.3, and we're dealing with current, so we have to think about what's the unit for current. It's the amperes. Okay, so it is 0.3 amperes. And this is just a unit that represents the flow, like it's a number of electrons that pass by a particular point every second on your circuit. So that's that one. Okay, so like very straightforward. We're looking for voltage in this one. This one asks us for current. So let's have a look at this last question then. So calculate resistance. Okay, so you've been asked to calculate the resistance. So again, what we do is we go up here to this guy here, and we're calculating resistance. So we have to cover resistance. So we can see that resistance is equal to voltage divided by current. So V divided by I. So we can just write in our formula. So R, which is the letter that we use to represent the quality or the characteristic of resistance, is equal to V divided by I. So it's V divided by I. So what we do is we read the question and then write in what we have. So we have voltage is equal to and current is equal to. So if we have a look, so calculate the resistance of a resistor when a potential difference of 12 volts. Okay, so the voltage is 12 volts. Causes a current of 0.2 amperes to flow. Okay, so our current is 0.2. So just remember, this current represents like the flow of electricity or the flow of electrons through a conductor, and then the voltage is like the push that's on it. Okay, the higher the voltage, the more push that's on the electrons, and therefore we know that with Ohm's law, as the voltage goes up, the current or the amount of electrons flowing in the conducting material increases as well. So if we have a look at these, so we take what we've got and we plug them into the formula. So resistance is going to be equal to voltage, which is 12, divided by 0.2, like so. And then what we can do is we can plug these in here. So we have 12 divided by 0.2, which is equal to 60. Okay, so our resistance is equal to 60. And if we remember resistance, the units for resistance is the ohm or ohms. So the resistance is going to be in ohms. So the resistance is 60 ohms. It's 60 ohms. So that's it. And that's how you do, like, these are the kind of calculations that you'd be asked to do for electricity, and this is basically how you do it. This triangle is very important to remember and to know this and know how to use it. And you just need to know, for example, voltage or potential difference, so that means the same thing. Current is in amperes and resistance is in ohms. And what else? And yeah, voltage, the unit for that is volts. Okay, and that's it. That's a review. So they're the calculations. That's how you work through the calculations as well. So I'm going to put up some calculations for you to work through. Make sure when you're working them out that you show, like, you follow this process. So put down your formula, write in what you have, put the details into the formula, put what you have, the actual values in, and then work them out and show your answer. So it's very important that you have these. You show the working out of your problem. Okay, thanks very much.